Okay, very good afternoon to everyone. So the previous class, practically we have seen how locks are being operated and how the locks are so having different kinds of conflicts while we are talking about the DML operations using locks. Everything has been seen in the previous session. And today we would like to study the theoretical approach of same locking, how the locks have been emerged in database management systems, not exactly in database management systems, in operating systems also, how the locks are being emerged and how the locks are being implemented theoretically, not practically, theoretically how they could be implemented. Let us have a look and let us take the session today. Okay. Now, generally, what are the types of locks which are being implemented in database management systems at earlier stages are so two different types of locks are there. Before going to take that, so what is a lock and how lock is being taken here in the sense, lock is a specific variable. Okay, it is a variable. Let me call it as a status. So status of one database item. Instead of I'm calling, this is actually taken from textbooks, but instead of taking that variable, I'd like to take it as a status, and it could be describes the status of the item, so which have been do some kind of possible operations in the sense data manipulation operations, all insertions, deletions, updations, all these operations on so that particular item will be called as lock. If lock status will be equal to 1, then you could not perform. I mean, whatever the database transaction which is being already occupied, that particular lock, so that transaction could only be done some kind of operations over there, and other operations or other transactions could not be performed any kind of operation over there. So other transactions could not be done any other kind of operations over there. Okay. So such kind of things will be called as a lock. And lock is being considered as a variable, more specifically speaking, status variable. Okay. Generally, there is one lock for each and every item within the database. If you consider a table can be defined by you, so within the table, for example, some 5 columns are there. Every column has its own lock. I mean, status of lock item. Okay, so that is what you need to consider or you need to remember. So I'm talking everything regarding to or with respect to only theoretical approach. So it is not true for practical approach. More specifically speaking, in Oracle, practically, so lock will be gets operated for table, but not so local level, otherwise row level. So for a particular row, you could not operate any lock. At a table, so yes, you can operate so the lock. Table level, you can operate the lock, whereas data level, it is not supposed to operate any lock over there. In SQL Server or MySQL or other application, other database applications, yes, data level also, data level in the sense row level, lock could also be gets operated over there. But here in Oracle, it is not possible. That's what you need to remember. And whatever the concept which I have to which we have to take in at this moment, that is only the theoretical approach, not the practical approach. Please remember this particular point before going to details about this particular lock. And as far as locks are concerned, these locks are used to manage the synchronization between so 2 or more transactions. Okay, if 2 or more transactions are there with you, then if you are supposed to follow some kind of synchronization, then locks are required. If synchronization could not be there, then DML operations will be operated at a at a worst case of scenario, so that you could not update the data in a proper way. So that is the point you need to remember regarding to the information of locks out there. And here, as far as the locks are concerned, so we have two different types of locking mechanisms out there. One is binary locking, and the second one is a read-write locking. Read-write locking in the sense share and exclusive locking. So we have discussed this particular kind of locking mechanism in the previous class. Of course, binary locking mechanism cannot be there in practical approach. It has been defined theoretically, and they have checked that whether binary locking is good or not. After that, the read and write locks have been introduced. Okay. However, let us take the information regarding to binary locks. Binary locks are two different types of values can be binary. Binary in the sense only two, bi in the sense two. So two different types of states of the locks will be there. That is, either it is locked state or it is unlocked state. Locked state will be always taken one as the status variable. Whatever the status variable you have to consider here. Before that, the definition of the lock has been taken as a status of that particular item. We have told that is we have quoted that is the status of one particular item. So that status value could be changed from 0 to 1 when we have to operate the lock, and when we have to operate this particular unlock, this could be changed from 1 to 0. Okay, so that is why we have only two states. Because of these two states, so we would like to consider that these locks will be binary locks. Okay, and a binary lock will be associated with each and every database item. Let me say, so X, where X will be called as a column name. It is not exactly one particular data item within the table. So it is a column name. For every column, there is one lock which is being associated with, and this particular value will be equal to, the status of that particular value will be equal to 1 when you have to operate lock on that particular item. I mean lock item of X. If you do operate something like that, then the status will be changed from 0 to 1. And so if any item, for example, user 1 will be there and user 2 will be there. For example, there is a table, and within this particular table, one particular data item is there. The status of this particular data item will be equal to 1, and which is taken by user 1 on this particular data item. Within this particular scenario, user 2 wants to get the status of lock item of the same X. Then it is not supposed to be allocated to user 2, because this item is already held up by one particular person, one particular user. That user is user 1. I believe that you have come across with deadlocks in your operating system course. A resource request and a resource allocate. So here it is, allocation must happen. Lock item will be gets taken by user 1. Obviously, this resource has been allocated to user 1. Now at this moment, user 2 has requested the same lock on X, then it is not supposed to be allocated, because it is being held up by user 1 here. So that is what the meaning of this particular sentence here. And then followed by, if the value of, lock value of X will be equal to 0, yes, it could be gets allocated to that particular user here. Okay, simply speaking, as per the operating system perception, we'd like to consider there is one particular item that is X, and the status of that particular X will be equal to 0 here. For example, it could be equal to 0. And let me talk about in terms of transactions. Transaction 1 will be there, and the transaction 2 will be there here as far as this one. And the transaction 1 has been operated. So log li, let me write li, log item of X has been gets operated here. So before going to allocate this X to this transaction T1, so database engine will be look forward that whether status of that X will be equal to 0 or not. If it is 0, yes, it could be allocated to transaction 2, transaction T1. Otherwise, if it is equal to 1, it should not be allocated. It could be, so this particular thing will be gets waited for some time. Of course, we have given a small algorithm for evaluating this one here. Now, if this is the case, yes, initially, so X status value will be equal to 0, lock value will be equal to 0. Yes, transaction T1 is requested for X. Yes, status equal to 0, T1 has been acquired and T1 is holding this X. Now, before going to hold this one, it must be changed from, so it could be always changed from, so this one, 0 to 1, and then so it has been allocated to T1. Now, after some time, after some particular time taking during the course of the time, so lock item of so X has been gets operated by transaction T2. Now this one in this particular scenario, so X is status of this particular X is already equal to 1. So since it is already equal to 1. So this transaction T2 must be wait for some time until the status of X will be changing from 1 to 0. Okay. So to evaluate this one, we would like to consider so a small algorithm here. Of course, before going to take that particular algorithm, so in transactions, theoretically in transactions, if you want to apply lock, so this is the statement you have to use. Lock item of X, unlock item of X could be gets operated by you in the binary locking mechanism. So look at this. So however, let me talk about these things after some time, after completion of this particular algorithm. So this algorithm is, if you are supposed to operate lock item of X will be gets operated by you, then what will be happen? Okay, don't worry about this B. B is label. This B is label. If lock of X, status of X will be equal to 0. Status of X will be equal to 0. Then what exactly you are supposed to do? That status must be changed from 0 to 1. 0 to 1. And then, if status of X will be changed from 0 to 1, obviously that item is being endorsed. Which transaction has been operated this particular operation first? Okay. If that is not the case, in the sense, if lock item of X is equal to 1, it is not equal to 0 in the sense, obviously the converse part will be equal to 1. What exactly it could be done? It could be done, so wait until the lock value becomes 0. Until the lock value becomes 0. It will be continuously sensed to the particular status of that item, lock status of that item. And so if that particular item will be still equal to 1, it will be put into waiting state. And after 2 seconds or 3 seconds, it will be again sensed, and so on and so forth. When the status of lock will be turns to 0, when the status of lock will be turns to 0, then the lock manager will be wakes up the transaction. So what does it mean? So the same story I would like to define here. Transaction T1 has been taken. So lock item of X has been taken here. And transaction T2, let me say transaction T2 also requested for, let me write here, lock item of X here. Okay, of X here. Now at this moment, status of this particular X will be equal to simply 0. Status of this one will be 0. Now in a course of time, transaction T1 has been operated lock item at very first. So therefore, since this particular condition will be true, that is lock item of X equal to 0. Let me say status of that lock will be equal to 0 as true. So therefore, it has been changed from 0 to 1, and the status will be captured by transaction T1. Okay. Now, yes, it has been taken the lock, and it is doing its operation. DML operations are being done by transaction T1 on X. It has been done. Now, in the course of time, so after some time, probably, so after application, let me say this is a delta t1 time, and let me say this is this operation has been operated delta t some 4 time. So at delta 4 time, so transaction t2 has been operated lock item of x. Now immediately the lock manager will be, database lock manager will be checks that, so what is the status of, lock status of x here? Here lock status of x will be equal to 1. Yes, so this condition is failed. Since this condition is failed, it will be wait up to what extent it is being waited? Until the lock state, lock status of the x will becomes 0. If it will become 0, immediately lock manager will be wakes up this particular transaction, and lock will be endorsed to or assigned to this particular transaction, and the process will continue. Okay, the process will continue here. So this is what when lock item will be gets operated by you. Whereas if you go ahead and of course, if when transaction will be gets waked up, then immediately it will be moved to this location, and this location in the sense here if lock item, because transaction T1 has completed somewhere else after T4, somewhere else at delta, let me say T20 at the time. So commit has been operated by, so this particular transaction T1. Obviously at delta 21, at delta T21 time, so the lock has been endorsed to this one. When commit will be gets operated, automatically status will be changed from the 1 to 0. If it is becomes 0, then it will goes to, if lock of x equal to 0, yes it is, then lock of x will be becomes or changed to 1 by here previously it has been done. So previously it has been done by T1, now it has been done by T2, and this particular item will be taken and could be executed right away from delta T21 time onwards as per this example. Okay, as per this example. When unlock item will be applied by you, what exactly could be happen? So immediately what exactly could be gets operated here is lock of that particular status of that particular item must be changed to 0. If it is 1, it could be changed to 0. If soon this particular lock will be gets changed, if any other transactions are requested for the same item, they will be waked up or they will be assigned so-called items status in first come first served basis. In first come first served basis. What does it mean? So let me open notepad here. So let us consider here a transaction T1 and a transaction T2, and a transaction T2 and a transaction T3. For example, there are 3 different kinds of transactions are there here. So at a delta T1, let me operate it. So lock item of X. This statement has been operated by so transaction T1. So in the beginning, for example, it could be gets operated in the beginning. And then the same operation could be took place by after some time. That is why I have given some space here by this transaction T2. After some time, so it has been gets operated. Okay, and during this course of time, this course of a period, so this particular operation, transaction T1 has been performing its own operation. So X will be equal to X minus 50. However, whatever the operation it could be perform. After some time, so wait for a while. After some time, so this particular operation will be gets operated. Unlock of X could be gets operated. When unlock will be gets operated, there are 2 more transactions are aspiring the same item X. So transaction 2 is ready to accept the X, and transaction T3 also ready to accept this particular item X for doing some kind of operations, DML operations. So soon it has been acquired in the list or in the ready queue or in the queue, so transaction T2 will be there and followed by transaction T3 will be there. After applying this particular transaction, T1 has been operating this unlock. So the lock manager will be assigns this item to transaction T2 because it is in so a rare end of this particular queue. Okay, so first come first serve basis. So T2 will be available in the rare end and sorry front end, not rare end. Sorry, front end. So therefore, it has been assigned, and T3 will be still wait for some more time until transaction T2 will be releases the lock. Okay, this is the point you need to understand regarding to. So the transactions are waiting, then waking up waiting transactions. What does it mean? That is the meaning here. Okay. So these are the points which we have to remember when lock item, unlock item will be gets operated. Okay. So here, look at this. Look at this. When we have to operate lock item, when we have to operate unlock item, there are 4 to 5 restrictions to be operated. There is lock item and unlock item. Let us see. Before applying binary locking, you have to follow. Look at this. A transaction T must be issue lock item before a read item or before write item. Either of these two, so you have to take into consideration. Lock item must be gets operated before read or before write. Okay, so read item followed by lock item is not so expected, that is prohibited. Otherwise, write item followed by lock item is prohibited. So it must be always so before any read item or write item. So that is the first restriction you need to remember here. So let me okay, after discussion of everything, let me show you whether it is true or false, where we have to operate this one here. Any transaction T must be operate this unlock after all read items and write items. Okay, after all readings and writings, you have to operate so unlock. Okay, before read or before write, you are not supposed to operate unlock item here. So you are not holding the lock, then how could you unlock that particular item? Lock has been held up by some other transaction, but you are trying to unlock that particular item. It is not possible to, because lock manager is always looking forward who has the lock. Okay, so that is why after all read items and write items, so unlock could be gets operated. Then a transaction T must not issue. You please remember this particular, underline this one, must not issue lock item if already that item is held up by some other transaction. Okay, you please remember, if this could be done, obviously the third point will gives you, if this could be even the lock has been operated by or held up by some other transaction, at that moment if you operate, then you will be put into deadlock mode. You will be waiting mode. Already we have seen the algorithm also. So transaction T1 is holding. Now transaction T2 will be gets operated over there. Then obviously you will be at deadlock mode. No operation will be done by you. And then fourth one is transaction T will not be issue unlock item unless already held up that particular lock by you. If it is not held up by you, you are not supposed to give unlock item, because the lock manager will be looking very carefully whether you have the lock with you or not. If you have lock with you, yes, you will go ahead and apply this lock item. Otherwise, you are not supposed to apply any lock item here. So let me show you how all these things will be. So let me write a sample transaction for you, how all these things will be depicted. Okay, let us consider transaction T1. So begin transaction. Okay, transaction has been get started. Then lock item, for example, that is A. Item name is A. And then read item, so A, you could take your item here. then you could perform your own operation. You have been fetching the data from a database on that particular item after acquiring the log. Then you have to perform your own operation. So that is A will be equal to A plus or A minus, or you could do your own operation. And then so write item, so whatever the modification you did, yes, you have to write that particular item onto the item at local buffer. After that, you have to release release that particular lock from that particular item. Okay, you may be release this one here. Then obviously you have to operate commit. If you operate commit in the sense, obviously it will be goes to server permanently. So this is a valid statement or valid transaction. So what exactly the transaction has been, I mean, these rules and regulations has been depicted you. So you have been operated this lock item before read or before write. Yes, before read I have been operated. Before read I have been operated. Yes, there is no problem at all. First statement is true. Second statement is, so you have been operated unlock item after all read and write items. Okay, look at this. This is read item and this is write item. Afterwards, I have been operated lock item, unlock item. Yes, it is also okay. And transaction T2. For example, if you consider transaction T2, transaction T2 will be taken into consideration something like this. Let me copy the same and will be considered as a transaction T2 also. She's also doing the same business with the transaction, the item A. Then now transaction T1 has been get started for its working. Yes, this statement is gets over and this statement is gets over. Two statements are, I mean, begin transaction is gets over, lock item also gets over. At this moment, lock item of A by transaction T2 cannot be issued. Why? If you issue, obviously you will be put into deadlock state. Let me write the same set of statements wait for a while. I'll open WinWord, then it could be very easy to understand because here table could not be drawn here, so that is why table could not be drawn. Yeah, I'd like to draw a small table for you, then it's very easy to understand. Yes, this is transaction T1. Yes, this is a transaction T1. Here it is, transaction T1, and this is a transaction T2. Now, so how the transactions are being executed? Let us have a look here. These are the statements which are being executed, and these are the statements which are being executed under transaction T2. So before going to take that one, wait for a while. Just wait for one moment. So here, this is timeline. The timeline could be taken. So let me consider. So timeline will be, so 0th unit of time, first unit, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, and so on and so forth. 10th unit of time and so on and so forth. Now you could say, so two transactions are gets over. Two transactions are gets over. Now two transactions are gets over. Now after second transaction, you have been started your work. You have been started your work, and I hope that you do understand so how the things are being happening here. Okay, look at very closely. After unit number 2, time unit number 2, transaction T2 has been started. It's working. So 2 and 3 begin, and lock item has been issued. At this moment, so since already status of that particular A has been taken by transaction T1, lock has been taken by transaction T1, now you have been issued here. You have been issued here. So transaction T2 will be put into waiting state. It will be put into waiting state because this particular lock has been taken by on A, lock has been taken by transaction T1. So because of this particular statement, so you will be put into waiting state. Then up to what extent you are supposed to wait here in the sense, you are supposed to wait until this statement will be issued. If this statement will be gets issued by you, yes, waiting state 2. So it could be executive state will be comes into the picture. So like this, it is being taken into consideration. So while you have to explain these 4 different kinds of operations here. Okay. This is what about a binary locking system. They're talking about a read and write or shared or exclusive lock. Already we have taken this one in the previous session in as a practical kind of approach here. So however, we would like to see again the theoretical approach. So binary locking scheme, you could see just before I have written something here, until unlock will be gets operated by transaction T1, T2 must be put into waiting state. If you take one more transaction, for example, one more transaction has been taken by me. So that is a transaction T3. Transaction T3 has been issued, and here also it would be executed in such a way that yes, a transaction T3 will be starts its work at so at this stage, read item. Of course, let me go further. So at second unit of time, begin transaction of 2, third unit of time this one, and fourth unit of time, so begin transaction and lock item of A. Now transaction T1 has held up item A, therefore because of lock item of A by transaction T2, it will be put into waiting state. And again, the same thing was operated by this particular thing, then it is also put into waiting state. When it could be comes out from the waiting state in the sense when T1 will be operated this unlock of A. If unlock of A will be gets operated by T1, then chance will be goes to T2 because it will be the front end of that particular queue or first to come of that particular queue. So the T2 will be taken. So until unlock, these 2 statements or these 2 transactions cannot be work anymore. So this is the restriction where so-called binary locking system will be taken into consideration. Okay, that is what you need to consider here. Binary locking system is too restrictive. Too restrictive in the sense once a lock has been held by some person or some transaction, remaining all other transactions who are aspiring the same item will be put into waiting state. They are not supposed to execute further. Okay. To make more and more flexible, so share and exclusive lock will be introduced. What is the importance of share and exclusive lock here? Transaction T2. Look at this. Transaction T2 want to read the item just so. That's all. Read the item. There is no write item or anything. Nothing is there. Just transaction T2 wants to read the item and looking into that particular item, that what is the status of, what is the value of that particular item. He is not, the transaction T2 could not done any kind of updations, any kind of other operations other than retrieving the data. Okay, for doing this particular kind of operation, so read or write lock or shared or exclusive lock has been introduced. Okay, so simply speaking, so there are for reading of one particular item, so conflict will be gets existed in binary locking system, whereas the same conflict cannot be there if you are supposed to use a read item or write lock and read lock over there. Okay, so because of read operations could not be gives you any modification on the database state or item state. There is no modification. You could not change the value. You could not insert new value for that item, or you are not deleting any item, any value from that particular item. So therefore, it could not be do any kind of modification on the item. So that read will be permitted for many people. But in binary locking system, even reading is also not possible. Even reading also not possible. So that is the problem here. So to evaluate that particular problem, so we have to take in shared or exclusive, otherwise read or write locks have been taken into consideration. So there are 3 different types of operations for this particular shared, exclusive or read or write operation. Number 1, read item on X, write item on X, and unlock that particular X. After reading, you have to take the value. So all the values, and locally you have to perform your own modifications. After modifications were happened at a local, at a web system, then make sure that that particular operation will be permanent at the database level, so that before going to make that particular modification permanent, you have to acquire the right lock. After getting the right lock, yes, you could perform your permanent of that particular operation. Then followed by you have to release the lock, which is the item will be available for some other people. Okay. So in this way, you have to take into consideration here. Okay. An item could be either it is readly locked or writely locked or unlocked. Okay. It could be taken into consideration. Read lock will be practically it is called as shared lock. Write lock will be practically it is called as exclusive lock. Of course, unlock will be always specifies commit. If you operate a commit, all locks, everything will be released. Not exactly locks, everything will be released. Okay. So to operate these read, write, and unlocks, what are the rules and regulations to be followed? Number one, a transaction T must be issued read lock, that is share lock, or write lock before any read item. Okay, either read or write before any read item. Okay, then a transaction will be issued write lock. If you want to issue write lock specifically, it must be issued only after a write item. Sorry, only before. Sorry, I'm very sorry. Only before a write item. It should not be issued. So because of this particular second rule, of course, here write lock will be eliminated from this particular statement. Okay, of course, textbooks have been given this particular thing also, but so logically, if you're speaking, so write lock item will be operated only before write item. Okay, so therefore it has been eliminated from here. Then a transaction must be issued unlocked. The third lock item will be unlocked after all read and write operations. Okay, after all read and write operation, you have to unlock the specific lock. The status will be released on that particular item. And a read lock cannot be issued. You please underline this one. Cannot be, will not be issued if it is already held by some other people. Okay, so some other people in the sense, if only shared lock will be gets operated, there is no problem. Only shared lock would be gets open, there is no problem. Okay, already we have seen in the previous class. But anybody will be taken this exclusive lock, then so read lock cannot be gets operated. Okay, read lock can be gets operated if so many people are taking read lock. Yes, it could be gets operated. There is no problem. If anyone will be taken write lock, read lock cannot be gets operated. Obviously, you will be taken so into what is that deadlock state. Already we have seen in the previous class, and so already seen. That is why I have taken as discussed in shortly. Already we have taken. Write lock has been operated so that you may be. I mean, any other transaction may be operated either read lock or write lock. Okay. Any transaction will be held up in read mode or write mode. You will never operate write lock. For write lock, if you operate after read or write lock by some other persons, then you will be put into so-called waiting state. Okay. Unlock will be issued by any operation that the specific item will be held up by some other transaction, not exactly you, some other transaction. So to satisfy these rules and regulations, I will write the transactions, which could be seems like this. Yes, you have to begin your transaction. Let me copy this one from here. Yes, your transaction will be get started here. Begin transaction. Okay. Then followed by so read underscore lock of item A. However, you can take your own item. Then followed by read item. So of A, you have to take the item. Then you have to perform your own operations. So A plus so A into so 0.12 percentage has been increased. Then followed by, before going to write, what exactly you are supposed to do? You need to acquire the write lock. Okay, therefore write lock on item A, then followed by write item of A, then followed by, yes, you have been written onto the local buffer, that is right. Then you have to unlock item, so A. Yes, you did this one. Obviously, chance will be given to some other party or some other transaction to perform the operations. Okay, so therefore it could be okay. Yeah, previously what we did, let me copy the same transaction in the previous way, in this portion. Look at this. Look at this. Okay, let me eliminate this one here. One extra statement will be, so not exactly one. So here it is only one lock item and unlock item. Only this particular thing will be there here. Only lock item and unlock item. Only these things will be there with you. But here, read lock and write lock. All read locks will be gets operated before going to read item. All write locks will be operated before going to write item, and all unlocks will be gets operated after read or write items. Okay, so this is the shared and exclusive lock pattern, how you have to operate it, and this is so binary lock pattern where we have to operate on single item. Okay, this is what the class today for our points here. Okay, so we shall come up with so extra operations by tomorrow, in the next hour. Where it is? Meeting is not stopped. Okay. Okay.